This is a short version of practice problem number 2 from Lesson 9, Moves in Parallel, and Unit 1, Rigid Transformations and Congruence. In problem number 2, you're to find the measure of each of these angles, angle CBA, angle ABE, and angle EBD, given this 45-degree angle for angle DBC. Now the relationship of this angle to a second angle that forms a straight line means that those two angles will add together to equal 180 degrees. They are called supplementary angles. And the relationship of this angle to the angle directly across from that angle through the center is that they are equal, and they are called vertical angles. So this angle right here is a vertical angle is equal to 45 degrees. This angle right here is a supplementary angle, is equal to 135 degrees. And this angle right here is another vertical angle, and that is equal to 135 degrees. So you can use a protractor to prove that going from point D all the way around to point A forms a straight line. So this 45-degree angle and the remaining size of this second angle, CBA, has to add to 180 degrees. So this angle has to be 135 degrees. So this angle right here is 45 degrees, and the remaining angle is 135 degrees. So this is 45 degrees, 100 degrees would be 145 degrees right to here, and then 145, this is 100 degrees from point C, 110, 120, 130, and 135 degrees. So this angle is 135 degrees, and these two angles are called supplementary angles. They add to 180 degrees, or a straight line. So this angle right here, EBA, adds to 180 degrees with this 135 degree angle. So it's 45 degrees. So this angle right here is 45 degrees. Here's 0. And to this point right here is 45 degrees. It's supplementary with a 135 degree angle. So they add to 180 degrees. It's also a vertical angle that forms with this 45 degree angle. So when you have two lines that intersect, the angle across directly through the intersection, those two angles are equal. So this angle is equal to this angle. So it's directly through the intersection. Vertical angles equal opposite through the vertex or center. In this case, they are 45 degrees. And this last angle, which is EBD, is 135 degrees. You get that a couple ways. It is a supplementary angle with this angle, which is 45 degrees, plus this angle is 135 degrees. It's also a vertical angle with this angle right here, ABC. So you go through the intersection to the opposite side. This angle is 135 degrees. So 45 degrees plus 135 degrees equals 180 degrees, a straight line. 135 degrees plus 45 degrees equals 180 degrees, this straight line right here. It's also a vertical angle with this 45 degree angle. This 45 degrees plus another 135 degrees forms a straight line right here. So they are supplementary angles. Also, it's a vertical angle with this angle right here. Go through the intersection, the opposite side. It's 135 degrees. And finally, 135 degrees plus 45 degrees forms another straight line this way. And they are supplementary angles once again. So using the idea of supplementary angles and vertical angles, given one of the four angles, you can always find the other three angles.